Hello, welcome to Calculus Chapter 1, Lecture 1. You don't need your book for this lecture. This is just an introductory lecture to answer really what is the purpose of calculus. Why can't we just use algebra? Why do we even need calculus? Okay, so the way I'm going to talk about this is calculus answers two major questions. Okay, I'm simplifying it a lot here, but let's just call it, at least in this course, the first question of calculus. So what I want to do is draw kind of a timeline. In fact, I'm going to move this down just a little bit. Didn't leave myself enough room. Let's say we have 0 and 30 miles. All right, we've got a bicyclist something like that. Not a great artist here. Not even going to put a person on it. And at the 20-mile mark, so 0 miles, 30 miles, we have a 20 mile per hour speed limit sign. And let's say this bicyclist rides 30 miles in 1.5 hours. All right. So the first question is, what is the biker's speed the instant he passes the 20 mile per hour sign? All right, did he break the law? So we're not asking what's the average speed. That'd be really easy to get. You would just take 30 miles divided by 1.5 hours and you get 20 miles an hour, right? We want to know what's his speed, but his speed could go faster, slower. He could speed up, slow down. What is the exact speed at the 20 mile an hour sign? Okay, so you might remember this equation from pre-cal. Distance equals rate times time. All right, and to get the rate, we would do distance over time. Okay, so the first question of calculus officially is, how do you find instantaneous rates of change? Okay, so that's the first question of calculus. All right, let's get into the second question of calculus. Okay, let's say we have a rectangle. You want to find the area of that. Well, we have a geometric equation, don't we? Area equals base times height. How about a circle? All right, we've got a geometric equation, pi r squared. A triangle. Right, do you remember what the area equation for a triangle is? It's 1/2 what? Base times height. How about the volume of a sphere? It's a terrible looking sphere, but I'm trying to, volume. It's a fancy one, 4/3 pi r cubed. But we do have an equation. If we know the radius, we can get the volume. But what if we have just some really odd shape? Something like that, some kind of blob. Or how about something like how about a football? It's football season as I make this video. All right. Put some laces on that thing. So what would be the volume of that? Okay, do we have an equation? Well, whereas geometry can answer these basic shapes, if we have really some oddball shapes, we want to know area or volume, calculus can answer those questions. So how do you find the areas or volumes of, let's call them exotic, for lack of a better word, shapes? And the two questions of calculus have related answers. Which is really pretty cool. And when we get there, it's kind of an amazing thing. Well, I'm going to cut this introductory video kind of short. And there's no homework involved with this video. And we'll pick it up on lecture number 2.